More examples relating to questions like those in exercise 10G. Just doing some examples here. So first example, a teacher wants to select 2 students from a group of 4 students. How many ways can this be done? So we know that how to do that already. It's 4 choose 2. And we know that if you do 4 choose 2 on your calculator, you will get 6. Okay, now I'm actually going to list, I'm going to say, right, let's say we've got the students are A, B, C, and D. I'm going to choose 2 students at a time. So I'm just going to show you those 6 ways. Now they could be A, B, or A, C, or A, D, or you could have B, C, or you could have B, D, or you could have C, D. Now, so they're the ways if the students are A, B, C, D. These are the 6 ways that you could choose 2 students from those 4 A, B, C, D. So there are 6 ways. It was 4 choose 2, which is 6 ways. Now that's fine. Now this second question, it says, in how many ways can a teacher split 4 students into 2 teams of 2? See, when you choose 2 students, you've automatically got your other 2 students in another team. So let's say we've got, again, A, B, C, D. So if I choose A, B, then C, D forms the other team of 2. If I choose, say, A, C, then B, D will form my other team of 2. And if I form A, D, then BC will automatically be the other 2 that I didn't choose, and they form the other team of 2. So therefore we've got how many ways can a teacher split 4 students into 2 teams of 2? I've got one way where you've got AB in one team and CD in the other team. The second way would be AC in one team and BD in the other team. And the third way would be to have AD in one team and BC in the other. So my answer to do this question, you would do 4 choose 2, but then you get 6, but then you have to do 6 divided by 2, which is 3. Because when you've got to divide your answer by 2, because 4 choose 2 gives you the whole 6 teams. But when you've chosen a team of 2, you've automatically actually chosen another team of 2. So you're actually doubling up on that. So you need to do, the way you do it is 4 choose 2 divided by 2, which is 6 divided by 2, which is 3. So be careful when they say in how many ways can say the 4 students be split into 2 teams of 2. It is 4 choose 2 to give you the 6 teams, but when you've chosen this team's automatically chosen, so you're actually doubling up on everything. So you need to divide your answer by 2 to get 3. So same sort of question here. In how many ways can 3 students be selected from a group of 6 students? Now that would be 6 choose 3. Now 6 choose 3 happens to be 20. Okay? Now, so I mean I could list them all out, but that would take me, I'd have 20 different groups to list out. So in this second part, it says in how many ways can a teacher split 6 students into 2 teams of 3? It's going to be the same as what we did up there. So we go, yes, we'll do 6 choose 3, which gives us 20, but then we need to go 20 divided by 2, which is 10. So the answer will be 10. Now I'm actually going to write out those 10 different ways just to show you that it does work just like we did here. So for example, let's say your 6 students are A, B, C, D, E, F. So I'm going to come up with 10 different ways of splitting the 6 students into 2 teams of 3. So first way, we could have A, B, C and D, E, F. That's one team, second team. Then we could have A, B, D with C, E, F. That's the second way. Then third way could be A, B with E, and therefore C, D, F would be remaining. The fourth way would be A, B, F. So A, B, F with C, D, E. See how I've got 8 groups? that's 8 of those 20 that I originally would have got, but I'm forming, every time I've got 2 here, I'm actually just forming 2 teams one way there. So that's why it's always divide by 2. The fifth, I'm going to miss out B in this first team now. So I'm going to go A, D, E with B, sorry, A, D, I'm missing out B. So A, C, D with B, E, F. I could do the sixth, I'll do the sixth team over here. I could do A, D, E with B, C, F. I could do A, D, F with B, C, E. I could do A, C, E, haven't done that yet, with B, D, F. I could do A, C, F with B, D, E. I think there's just one more to go. I think I've missed, and then now I'll miss a C. I could do A, D, well, I've done all those, A, D. I could do A, E, F, haven't got one of those. There's no A, E, F. See, there's all the A, B combinations. I've got the A, C combinations, 3 of those. I've got the A, D combinations. And now the A, E, F with B, C, D. So notice there are 10 ways in which a teacher can split 6 students into 2 teams of 3. But it is 6 choose 3, and of course then you divide the answer by 2, or you can just do it in one step. 6 choose 3 divided by 2 is 20 over 2, which is 10. Okay, that's why we're dividing by 2, because every time you choose this, you've automatically formed that one as well. Okay, now for question 20. This is from exercise 10G. It's question 20. And the question says, find how many ways 2 numbers can be selected from the numbers 1 through to 9 so that their sum is even. Now, to get an even number, you can either, to get an even number, you could add 2 odd numbers together. They always give you an even number. So you could do an odd number plus an odd number. That'll always give you an even number. Or you could do, now if you add an odd number with an even number, like 3 with 4, you get 7, which is odd. So you can't do an even and an odd. Or you could do an even number plus an even number. Okay? So we've got an odd number and odd number, or an even number and an even number. That is how you can get the sum of 2 digits being even. Now, if we look at the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, we've got, just looking at our set, we've got 5 odd numbers and 4 even numbers, because our odd numbers are 1, 3, 5, 7, and 9. And our even numbers are 2, 4, 6, and 8. So if we want the sum of 2 digits to be even, so an odd number and then another odd number, we would represent as, we've got 5 odd numbers to choose from, and we're choosing 2, so it would be 5 choose 2. Now, or means plus, you always do plus for or. For the even numbers, we've got 4 choose 2. So we would have 5 odd, we could choose 2, that would always give me an even answer, or, which is plus, we've got 4 even and we could choose 2. Now 5 choose 2 plus 4 choose 2, just doing that on your calculator, you will get 6, which is 16. Now, find how many ways 2 numbers can be selected from those numbers 1 through to 9 so that their sum is odd. So if you want to get an odd sum, the only way you can get an odd sum is to have an odd number and then an even number. So odd numbers, there are 5 of those, so it's 5 choose 1. And even numbers, there are 4 of those, and we need to choose one of those as well. So it's 5 choose 1 times 4 choose 1, which is 20. So there are 20 ways that you can choose two numbers so that their sum is even. So we had an even sum of the digits and an odd sum. Part C of the question, find how many ways two numbers can be selected from these numbers 1 through to 9 so that the sum is divisible by 3. Look, the only way I can think of doing this is to write them out. So we know that 1 and 2 will give me a divisible by 3. So the sum of 1 plus 2 is 3, which is divisible by 3. We could have 1 with 5. 1 and 5 is 6, that's divisible by 3. We could have 1 and 8. 1 and 8 is 9, that's divisible by 3. So starting with 1, I'd have 1 with 2, 1 with 5, 1 with 8. Starting with 2, 2 and 4. Now I don't choose 2 and 1 because it's the same as choosing 1 and 2. So 2 with 4, 2 plus 4 is 6, that's divisible by 3. 2 plus 6. 2 plus 7 is 9. That would be divisible by 3. Then let's start with the 3's. Now you don't do, we can 3 and 4, 3 and 5, 3 and 6 is divisible by 3 because that's 3 plus 6 is 9. We could do 3 and 9 is 12. That's divisible by 3. Then we start with the 4's. Notice we're not going to go back to 4 with 2. 4 and 5 makes 9, that's divisible by 3. 4 and 8, that makes 12, that's divisible by 3. Now starting with 5, we don't go backwards. 5 with 4 we don't do because we don't want to go backwards because we've already got 4 and 5 together. So 5 with 7 is 12, that's divisible by 3. Then 6, 6 and 9 is 15, that's divisible by 3. And 7 with 8 is 15, and that's divisible by 3. So find how many ways two numbers can be selected from the numbers 1 to 9 so that their sum is divisible by 3. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ways. Similarly, for the sum being divisible by 5, you just do it the same way. Just start with 1 and see what it can be paired up with. 1 plus 4 is 5, that's divisible by 5. 1 plus 9 is 10, that's divisible by 5. Let's start with 2. 2 plus 3 is 5, that's divisible by 5. 2 plus 8 is 10, that's divisible by 5. 3 and 2 we don't do because we've already got 2 and 3. So 3 and 7 equals 10, that's divisible by 5. 4 and 6 makes, we don't do 4 and 1, it's already done. 4 and 6 makes 10, that's divisible by 5. We can't do 5 and 5 because it's the same number twice. We can do 6 with 6 and 7 doesn't work, 6 with 8 doesn't work, 6 and 9 is 15, which is divisible by 5. We can try 7, 7 and 8 makes 15, that's divisible by 5. And the only other one is 8 and 9 makes 17, that's not divisible by 5. So therefore we've got 1, 2, 3, 4, 5, 6, 7, 8 ways. Okay, so that's our set. So they were the sets, and they're the answers, 12 ways and 8 ways. Now for the last question here, for the sum to be divisible by 3, to be divisible by 3, it means that it has to be divisible by, to be divisible by 6, it needs to be divisible by 3 and divisible by 2. So we just need to go up and look at the answers where they're divisible by 3 and see which one of those are also divisible by 2. So that would be 12, 18. So the divisible by 2s are also the even ones. 24, 36, 48 and 78. So that is a total of 1, 2, 3, 4, 5. I'm getting 6 ways. Just hold for a sec. Actually, I have made a mistake, not thinking here. I've got the numbers there that are divisible by 6. So they need to be divisible by 3, the sums of the numbers, not the actual numbers. So I've done the wrong thing there. Sorry about that. I'm not going to delete and go back on the video. So we need the sum to be divisible by 3 and the sum to be divisible by 2. I just think it'll be easier if we, instead of doing it like that, I think we should just look here. 1 plus 5 is 6, that's divisible by 6. 1 plus 8 is 9, that doesn't work. 2 plus 4 is 6, that's divisible by 6. 2 plus 7 is 9, that doesn't work. 3 plus 6 is 9, that doesn't work. 3 and 9 is 12, that's divisible by 6. 4 and 5 is 9, that's not. 4 and 8 is 12, that's divisible by 6. 5 and 7 is 12, that is divisible by 6. 15 is not divisible by 6, and neither is 15. So the answer is that there are 5 ways. So sorry about that mistake again, but you can just fix that, okay? I was looking at the actual numbers as opposed to the sum. Wasn't reading the sum of the digits is divisible by 6, so I actually didn't read that correctly, so it's just done the same way as the others. Now, question 22 is similar to those examples I did earlier on. We've got 9 players are divided into 2 teams of 4 and 1 umpire. So the first question is, in how many ways can the teams be formed? So we've got a few ways of doing this. We've got 9 players, and I'm going to choose one team of 4, which is 9 choose 4. And then I've got 5 players left, so I'm going to choose 4 again. But notice I've got 2 teams of 4 here forming. Once I've formed this one team of 4, then these others automatically get formed, but I know I do have, and then there'll still be one person left over, which is times 1 for the umpire. So as we did before, we need to divide this answer by 2, because we're going to have, we're actually going to have the 8 teams formed, but I'm not worried about I'm not worried about the 8 teams, because every 2 teams makes one group, because if you've got 4, you've automatically got the other 4. So we need to divide that answer by 2 like we did in those examples I did earlier. So if you work that out, you get 315. The other way you can do this is choose your umpire first, so 9 choose 1, and then you've got 8 players left, so 8 choose 4 times 4 choose 4. Now we know 4 choose 4 is just 1. So, and then you need to divide that by 2, because once you've chosen these 4, the others automatically get chosen. So that's why we need to divide it by 2. Otherwise you're counting the 8 teams rather than the 2 teams of 4. And if you do it that way, you also get 315. Now, for part B of question 22. If 2 particular people cannot be on the same team, how many different combinations are possible? Rather than trying to work out putting them in different teams, I think it will be easier to work out if they are on the same team and then do your total minus those 2 people on the same team. So what we're going to do here, we're going to do the total combinations, which we had in part A, minus the number of combinations with 2 people on the same team. So we're using like complementary results. So number of combinations with 2 on the same team will be, now what we've got to do, if those 2 people have to be on the same team, I'm going to put those 2 people as 1, and then we've got so we've got 2 people there, that's 3, 4, 5, 6, 7, 8, 9. Remember, one of them's got to be the umpire as well. So number of so we've got 1, 2, 3, 4. So we've got 1, 2, 3, 4. 1, 2, 3, 4, and the umpire. So number of combinations with 2 people on the same team. If these 2 people, for example, have to be on the same team, because remember we're doing total combinations minus number of combinations with 2 people on the same team. So if these 2 people have to be on the same team, so they're one choice, they have to be there, then I need another 2 more people on that team from 1, 2, 3, 4, 5, 6, 7. So it's 1 times 7 choose 2. Then so we've got 4 people on one team. Then for the next team, there's 5 people to choose 4 from, so it's times 5 choose 4 times the 1 umpire. Okay, now because these 2 particular people got chosen first and then we're just adding another 2 of these people to the team, we're not going to do this divide by 2 thing because this is quite specific about that particular group. So we don't need to divide by the 2. So we've got 1 times 7 choose 2 times 5 choose 4, and that equals 105. So therefore, number of combinations with 2 people not on the same team will be the total that we had from the first part, which is 315 minus 105, which is 210 combinations with 2 people not on the same team. Okay, now that's it for examples from exercise 10G. Now, actually there is one more question in exercise 10G, it's question 25. Now it says here in this grid, the diagram shows a grid measuring 4 centimeters by 6 centimeters, and the aim is to get from point A in the top left-hand corner to point B in the right-hand corner, bottom right-hand corner, by moving along the black line. Now you either move across every time, so you can go across or down. So you can go across or down every single time. So now a single move is defined as shifting along one side of a square, either across or down. Okay, thus it'll always take 10 moves to get to B. I mean, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or I can go along there 4 and down here 10. And even if you zigzag, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no matter which way you go, it will take 10 moves provided you're not going backwards. Now it says how many routes are possible. Now because to get from A to B, you have to go 4 across. You're going to have to make 4 moves across and 6 moves down. The number of different routes will be 10 choose 6 because you're making the decision to either go down or across, or because there's 6. The reason is that there are 6 squares down, or 10 choose 4. Now, if you do 10 choose 6, you get 210, and if you do 10 choose 4, you get 210 as well. It's because I quickly showed you Pascal's triangle, but there is symmetry with this notation. 10 choose 6 is actually equal to 10 choose 4. So because there's 4 ways across and 4 squares across and 4 squares down, the ultimate choice is to whether you're going across or down. So if you're going the crossways, there's 4 and there's 6 choices about going down. So it's either 10 choose 6 or 10 choose 4, which is 210. Now the reason this works is because you must move 6 down in 10 goes. Or you can look at this way and you say, well, I must move 4 across in 10 goes. So either way it will work, and it's because 10 choose 6 equals 10 choose 4 that either of those will work. Okay, I know this is a little bit different, you haven't seen anything like it, but I suppose that's the only way I can explain it. All right. B, how many different routes are possible if you must pass through C? Now if you have to pass through C, you've got 1, 2, 3, 4. You've either got to go 2 across to C or 2 down to C, and it's 1, 2, 3, 4 moves to get to C. So it's 4 choose 2 to get to C. It's because there are 4 moves to get to C, and you must move either 2 across, or you could be looking at it as 2 down. Okay? Then from there, we've got another 6 moves, 1, 2, 3, 4, 5, 6, 2 across or 4 down. Then it's times 6 choose 2 or 6 choose 4, whatever you want to use. I mean, we might just be we could just be not systematic, but consistent, sorry, and say we're just going to work with the across bits, and we've got 6 moves now to get, 6 moves to get from C to, so the first one was 4 moves to get to C from A. This is 6 moves to get from C to B, and you must move, you know, 2 across. Now notice, or I'm going to put 4 down. So we could have done that, or we could have done 4 choose 2 times 6 choose 4. Reason is 6 choose 4 equals 6 choose 2. Okay, so either one would have worked. And the answer for that is 90. Okay, now for part C, how many different routes are possible if you cannot move along the top line of the grid? So for part C, so let's have a look. How many moves are possible if you cannot move along the top line of the grid? So if you cannot move along that top line of the grid, you must have to come down here first and start from there, from the point below A. So if you can't move along the top of the grid, you must start from directly below the point A. So therefore, so you must go, if we're going to do a cross, you must go 4 across from only 9 moves left, because that 1 move going down is definite. You're not allowed to go across. So that 1 move down is 1. And so now you've got 9 more moves left and 4 across. So it's either 9 choose 4, or we could have done 9 choose 5 if you're looking at the downwards way. We don't do 10 choose 5 because then that's allowing you to go across or down. So 9 choose 4 will equal 9 choose 5. This is looking at 4 across, or this is looking at 5 down from that point below the A. And sorry, you can't see that properly. And that answer is 126. So you'd get the same answer. And for part D, it says how many different routes are possible if you cannot move along the second row from the top grid. Now, if you cannot move along the second row of the grid, then you have to go across 4 still, but you're only allowed really 9 moves because you've got to bypass the second row. So if I just put that back up there, if you are not allowed to move along the second row, let's say you've moved along the first row here and I move down here, but I'm not allowed to go across there, so I have to make a continuous move all the way down the second, past the second row. So what we've got to do here, so the question was, in how many ways can you move, how many routes are possible if you cannot move along the second row from the top of the grid? So you're effectively moving, only doing 9 moves now. So it will be 9 moves only, and you're still going 4 across. It's either 9 choose 4, or instead of 6 moves going down, this move here is always considered 1 move, or it's 9 choose 5. So in other words, you are only allowed 9 moves with either 4 across or 5 down, as the move must go from the top row to the third row, because that vertical move, as the vertical move must go from the top row to the third row, because you can't stop or move along the second row. So it's 9 choose 4 or 9 choose 5. That would give you the same answer, which is 126 as well. Now that is definitely now the end of this video for harder questions in exercise 10G. Okay.